All right, there we go. Hey, well, welcome everybody once again to Astronomy Daily Live. Hope everybody's doing well out there in the universe and the world. I'm going to pop over to my chat really quick to make sure no shenanigans. No shenanigans so far. Very good. Excellent. I'm actually going to scooch this. I'm going to scooch this over here today. Just because I can. All right, well, cool. Well, so come on in, everybody. Come on in. Welcome. This is a daily live stream, at least mostly daily. Once in a while. Oh, I'm hearing a little bit of echo from our panelist there. So I might as well do the intro to the panelist, the almost always there panelist, unless he gets booted off. Bobby, hey, what's going on?
Oh, praise the Lord on that. Yeah, so I'm gonna have to go with a different ways and means until Google can wake up and smell the roses.
Okay. Well, that's how it goes. At least there are alternatives. So and actually, yeah, this exercise got me to actually put a little Google Hangouts extension onto my Chrome browser. So yeah, you know, if need be, I can at least attempt to you know, do more of the administrative types of things. Now, no, you're not going to drink any of that HOH. This is the special HOH for the live stream. Yeah. So come on in, everybody. Welcome. We're gathering here on this virtual porch or around this virtual campfire, and I do not want you drinking out of that. No, you've got your own big, huge mug right over there, but you insist on drinking out of this one. What is that all about? I don't know. Anyway, so grab your favorite consumable and let's sit back and enjoy some astro talk and space and science and all things nerdy and all that. Hey there, Andy Cowley. Nice to see you in the chat. Hope everybody's doing well over there.
I wonder if there is actually no personal shenanigans. I think we can start with my latest from the ISS SSTV captures.
Yeah, let's take a quick look at that, and then we can get into some other things. I noticed that you posted a couple of those, a couple of new ones over there today. So actually, let me get that pulled up so I don't have to mess around with that too much. So, all right, cool. Now I am ready. So come over here and we're going to share the screen and we're going to do that. We're going to go to infinity. I have to look around the cat because otherwise I cannot see where I'm going there. And let's see. Oh, so let me do this, and then let me do that, and there we are. So here's the first one.
Yeah, I don't know why it was like backwards and something like that, but this is like a 65-degree pass. And I think there might be something in the programming in the ISS side that's causing a slant like that.
Yeah, I was wondering about that. Does that does that have any, I mean, I don't think that that has anything to do with the Doppler shift, right? I mean, that looks like a timing thing of
or
some
the
sort.
decoding and stuff like that. So
Yeah, it looks like a timing thing though, and it's gradual, right? I mean, it starts out as nothing and it sort of gradually grows. It's kind of hard to tell if it's linear growth or some kind of exponential growth there.
yeah,
But
I can definitely. I mean, if I still have those images, as I did, I pretty much like kept on erasing and back, and I never backed up. I was like, dude, I need to back up. I keep forgetting to back up. And I was
well,
like,
yeah,
I never make the time to back up. What the deuce?
yeah, you
And
need,
sometimes in those radiogram FFSK images, I mean, you can tell if there's going to be a slant for sure, and then and sometimes maybe you get like another like this. I think this was more of a programming. If I could have showed you another image that made like an MFSK image that has slanting for sure, then you might be able to tell more and stuff.
so you think that this thing over here is the software, not the signal,
Um,
or do you think it's
well,
the
yeah,
signal?
I think is I think there might be something that is like in the on the ISS that's causing that.
Gotcha.
Like
Because
I said, I saw like a slant, like an
yeah,
actual slant picture,
right.
and I don't think this and that's usually not a normal slant.
Gotcha, gotcha. Because yeah, I would think that at least towards the end here, you would actually be able to hear that, right? I mean, it would make a distinctive sound really, really fast, right? I mean, it'd be like a fast blip, and then the rest of the row, right, would fill in. So you'd probably be able to hear that, especially down here. But well, cool.
Yeah,
So that's a nice clean image, right? I mean, there's a
yeah.
little
Like I
bit
said, a like a 65, like
sweet.
about 2230 UTC.
Yeah. So how long does it take to actually grab an entire image here?
Man, I wish I have a stopwatch for it, but I think it take about like maybe 2 minutes and stuff.
Okay. I know actually, I think Gilles just posted a video about a couple of his captures. So I should actually look at those and see. But
Yeah, I think he also got those issues as well, and me and Jill's use the same app as well.
yeah, I gotcha. Okay, so here's another one, which obviously, the signal isn't quite as
Yeah, I
good.
think this one was like maybe like a 50 degree, but and I think it's caused by the like the clouds and stuff like that. Because I think Jill's told me one time that there should be no technologies that should be obstructing that signal. Only by nature and your environment can obstruct that signal for sure.
Hmm. All right. Yeah. And
Because
like you
yeah, I
said,
usually like blame it on technology, but that's but
yeah,
uh,
yeah. Well, that's, that is one of the interesting things about radio, right? And I mean, well, light in general, but radio, I mean, can be affected by, lots and lots of things. So yeah, yeah, cool. And I see that,
yeah,
you
that
know,
little issue again.
yeah, you're getting the same sort of effect here.
Yeah.
Yeah, yeah, I would think
You
that
know
that.
what's a good person to follow if you're still on Twitter or something?
Huh.
Follow whose username goes as KAEDOTCOM and SW Radiogram, and maybe ask, his name is Cam Andrew Elliott, about slanting in MFSK images.
Oh, okay. Yeah.
Yeah.
Yeah. Kind of cool, though. Kind of cool. So, all right. Well,
And
excellent.
there, I'd like to
Excellent.
welcome Chuck in
Hey there,
the
Chuck.
chat.
Yeah. Nice to see you
Haggle
again,
'em.
Chuck. Yeah. Excellent. Excellent. So, so yeah. Um, uh, so the other day, I learned that there was going to be an occultation of the bright star Sirius by an asteroid, and it was going to be happening at, at least in terms of UT on the 19th of February, and so I'm like, oh, okay, that's kind of cool. And so I went over to one of my favorite sites, which I'm going to show you here, and I took a look. I think it was yesterday. I think, and I took a look, and the predicted path had it going right over El Paso. It was sort of a south to north path, sort of curved because primarily because the Earth does seem to be a sphere, right? So it was sort of a curved path that was going right over El Paso, right? And I'm sort of like, wow, that's kind of close to me. I mean, not really, right? I mean, that would be a serious drive, haha. Um, and so for at least a couple of moments, I'm sort of like, maybe I should think about doing that. And after about 5 seconds or so, it's like, nah. The length of the occultation was supposed to be like maximum about like 1 second or so. The interesting thing about this particular event, though, was that I guess if you do the calculation, right, the apparent and calculate the apparent size of Sirius, right, which is going to be, micro arc seconds, right? I mean, really, 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 really small. Um, but you also calculate the apparent size of the asteroid, right? Which is also going to be in micro arc seconds. Well, it turns out that at least according to what I read. Now, I didn't actually do the calculation. It's a pretty easy thing to do, but the apparent size of the asteroid was actually smaller than the apparent size of Sirius. And so, technically speaking, right, you wouldn't necessarily have an occultation, right? An occultation, I believe, is when an object, completely blocks the background star, right? Totally blocks. But instead, what you would have, technically speaking, is like a transit, right? Where the I don't have any props here, so yes, I can do this, right? So if this is here, I've got a disc, right? So if this is the apparent size of Sirius, right, and this is the apparent size of the asteroid, right, then as the asteroid passes in front of Sirius, some of the light is going to be blocked, but not all of it, right? As opposed to, if Sirius, well, just the other way around, right? If this is the apparent size of Sirius and this is the apparent size of the asteroid, right? Then it's going to completely block it, right? And all the light is going to go away, right? as opposed to this where, you know, just some of the light. And apparently, according to the calculations, which I didn't confirm, it was going to do this kind of thing. Now, this ratio is wrong. I'm just, you know, showing an example here. And so what you would see is not Sirius actually completely going out, but just, you know, very, very briefly getting fainter and then brighter, right?
So
And,
what
you know,
makes you think that it's better if you don't do that obsession on that?
Well, the primary reason is because it being that far away, it's sort of like, well, that's too far. And two, I don't really have the equipment, you know, to properly make a measurement, you know, with all the timing and everything. That would and actually Uncle Bill, he reminded me that I do have a webcam that probably would actually work, right? So I could get 30 frames a second and actually probably make a pretty good recording of that, right? So, and he also mentioned that, you know, I'm almost close enough to probably at least give it a try, because, you know, we don't know the orbits of these things really, really well, right? You know, we know them moderately well, but not incredibly precisely, right? So, you know, just because it's predicted to go over El Paso, right? Well, maybe it will and maybe it won't, right? Who knows, right? So, thinking about all this, right, Uncle Bill, thank you. I'm like, well, you know what? I should look into this a little bit more, right? Well, it turns out that overnight, they recalculated the prediction for this occultation, right? And it turns out that now the predicted path is actually uh, quite a few 100 miles, maybe 1,000 miles east, right? It's going to be going over the Caribbean now, right? So it's not even going to be going over the United States at all now, right? At least that's the prediction, right? So of course that you know completely stops me from wanting to do that at all. But it sort of gave me an excuse here to actually, I will, and I haven't shown you all this site in quite a while, so I'm going to again. I'll put a link to it in the chat, so if you want to follow along, you can.
And I'm just gonna give you like a warning for tomorrow. We're gonna be doing another WWE pay-per-view viewing party.
Oh, sweet. Well, hopefully you'll have fun with that. That's what it's all about. All right, well, cool. So let's go over to the site and we'll take a look around a little bit here. I'll just sort of show you. And there's actually two sites I use.
And I think after you do that, maybe you can, like, if there's like another meteor shower coming next month or something.
Oh, there are meteor showers all the time. Yeah, we can definitely look into that. Yeah, for sure. Okay, so here's the asteroid occultation page, and I'm going to zoom in a little bit here so y'all can see it a little bit better. So this is kept relatively up to date. What you'll see in this table, right, is the event date and time, right? And this is all UT time, right? So you have to make the proper corrections for your local time. I'm not quite sure what rank is, but that's all right. Here is the asteroid that is doing the occultation, right? And here's the star that is being blocked, right? And then these guys are sort of nice enough, to give us a general, extremely general area as to where this event is going to be seen, right? And they list some other info here, which I forget. Oh yeah, so this is
like a duration.
Yeah, well, this is the number of magnitudes that the star is going to drop, right? So 7.1 magnitudes. It's going to last 1.3 seconds. And I don't remember what A is. Let's
I think it's like azimuth or something.
Note that this is the maximum altitude of the star. Okay, cool. So, but if you want to get details, what you do is you click on this date link. And what this date link is, this is the last time that software was run to predict where and when this event is going to take place, right? So what I do, right, is I just sort of look down this column here and see if there's any, that are sort of in my area. And since I do my area all the time, let's do somebody else's. Let's I think Andy, you're over in the UK. Is that right? I think so.
Yeah, Andy.
Yeah, I think Andy, you're over.
I'm in the like southeast.
Yeah, but that's right. So that's the United States, and that's fine. But I sort of thought, that maybe we could look elsewhere in the world. From the UK. So, yeah, cool. Okay, so let's look for some. So let's look for some UK passes. The cool thing about these occultations is that regardless of where you are on the planet, I
think if it just say Europe, then I'm for sure that Eddie will be able to see it.
Well, we'll have to look, right? But what I was going to say is that regardless of where you are, you can usually observe several of these each year, right? At least a couple, right? If not more, right? Texas. So yeah, let's
sort of from the to the neighborhooding state west of me. I'm from Louisiana.
Yeah, cool. So let's go down here and see. So here's a Europe one. Let's try that one. And that's a pretty bright star, magnitude 10.5, right? You can see that in a normal size telescope. So if you click on this link, what you get is a little globe, right? Which you can zoom in on here, and you can actually see what the path is, right? And unfortunately, this is definitely not going through the UK, right? So let's go on to.
Wow.
So let's go on to the next one here. Australia, Russia, Eastern Canada, Africa, Brazil, Canada, USA, Japan. Here's another Europe one. Okay. Going in front of actually, it's kind of interesting here, right? The asteroid is actually brighter than the star itself. Kind of interesting. um, so actually, for a moment, right, the star, I think, is going to appear brighter than what it normally is. This would kind of be hard to see, though, right? But let's take a look anyway, see where it's going. Ooh, that one's going over the UK, right? Very, very cool, right? At least according to the prediction that was made on this date, right? As of January 18th, right? So, but it sort of looks like it's going over, you know, the UK there, right? And they give little timestamps here. Let's go to the top, right? So here is the name of the asteroid, Kaluta, I guess, or Saluda. Never heard of that one. Anyway, that's happening on February 27th at 2 hours 15 minutes. At least that's when it starts, right? And that's right here, right? So you can sort of see these are little timestamps, right? So 215, 216, 217, 218, 219. So around 219 UTC on the 27th, this asteroid will appear to pass in front of this star, right? So, as I said, this is sort of a poor example because the magnitude drop, I guess if you can call it a drop, is only 1/2 of a magnitude. So that's going to kind of be hard to see. And you are looking for a magnitude 13.6 star, right? So that's really, 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 really faint. That's kind of a hard one.
I also see if you go to the white, you might be able to have more information about the asteroid.
Yeah, yeah. Anyway, what I like to do next is actually go to another site. It's called Point Source, and here, this guy, and I'll paste this onto the chat as well. Hey there, Atta. Nice to see you.
Hey, Atta.
So this guy here has actually projected these paths onto a Google map, so you could zoom in and actually see exactly where it's going. Okay, so this is Saluda.
Atta, live long and prosper.
Yeah. So Saluda on the 27th is right here, right? So here's the same event, right? But we can go to a Google map and actually pop it up here. And so there's the path, right? So that's where it starts. That's where it ends. So we can actually zoom in anywhere, of course, because it's a Google map. But let's zoom in on at least the UK and sort of see where this is going. So might be a little bit hard to see, right? But this green line is sort of the predicted center line, right? The gray line is the size of the shadow of the asteroid. I think the blue line and the red line are some kind of error bars, right? So I mean, what they're basically saying is that anywhere between these two red lines, you have a pretty good chance of seeing it, right? So if you're in London or Oxford or Cambridge or Dublin, right, you might have a pretty good chance of seeing this, right? If you're in Manchester or Leeds, kind of unlikely, right? There's always a possibility, right? But maybe not. So, Andy, yeah, depending on where you are and what kind of telescope you have, because you're going to have to.
If Tim Robinson was going to watch this later on, I think he's from Southampton.
Oh, okay, yeah.
I forgot where it was.
Yeah, I mean, like I said, though, you would need to have a pretty sizable telescope, right? You'd need at least a 12-inch telescope, if not larger, to really see this. So, this isn't the best example in terms of seeing things. And what this side also does is it gives you little finder charts, right? So it'll actually show you where in the sky, right? So here's a wide field view. Here's the constellation Leo, right? Here's Leo Minor up here. And this little crosshair here is where that event is going to take place. So what you can do, so that's a wide field. Here's a narrower field, right? So here's the head of Leo now, right? So what they've done, right, is they've said, okay, here's the widest field. This box here is this next field down, right? And then this box is the narrower field of view, 5-degree field of view, right? And then there's a 2-degree field of view, right? And then there's a 1/2 degree or 30 arc minute field of view. And I don't know if you can see that or not, but there's a little tiny black dot right over that crosshair. And that most likely is the star that's going to be occulted. So this is how you would go about figuring out which star is actually going to be occulted. You use the finder charts. That is, the best way. But I would say for sure that this one is definitely not a good candidate, right? Just a little too faint. So let's go back to our list and see if there's another one in the UK. Japan. Here's another Europe one. Let's just sort of see what that one is saying. Maybe. That's going through the northern part of the UK. So, and let's see. Well, this is a much brighter star, right? Magnitude 10.4. The duration of the occultation, the maximum at least, is almost 5 seconds. So, that's not bad, right? I mean, you would see the star disappear. You'd be able to breathe at least once, and then it would reappear. Yeah, kind of cool. It's really, really, really amazing to actually see things happening in the sky, right? If you haven't seen an occultation yet, I highly recommend it. It's a rush. It is definitely a rush. The asteroid itself is way too faint to actually see, right? It's almost 15th magnitude. At least according to this, it's a 34-kilometer diameter asteroid that subtends 25 milliarc seconds of size. So that's actually, at least as far as the apparent size goes, that's pretty big. right? That's pretty big.
So she will have to use the observatory equipment to see any of that, even if it passes over her area, because her 8-inch just won't do it.
Your 8-inch will easily see a 10th magnitude star. Easy, no problem, Ata, at all. No problem at all. No, you'd be able to see that one. But it has to pass over you too, right? And it is not. All right. So let's keep going here. That looks like a pretty good one for the northern part of the UK. Let's see if we can get more of a chunk of the UK. So here's one going through Europe again. It's a 12.4 magnitude star. Again, that's really, really faint. Really faint.
So the higher magnitude, the fainter, right?
Correct. Yeah. You know, these astronomers, they like to do things in really weird ways. So the larger the magnitude number, the fainter the object actually is, right? Okay, so here's kind of a neat one, right? Here's a magnitude 10.8 star that's being occulted by the asteroid Eros, which is sort of a well-known asteroid. Let's see. It says it's going through Europe. Let's see what kind of Europe. Okay, yeah, it's going through Spain, Portugal, Greenland. It's missing the UK there.
Wah, wah, wah.
Wah, wah.
Bah.
But as you can see, right, these paths are straight paths, right? The only reason why they look curved like this is because of the projection, right? This straight path, right, is being projected onto a sphere. And so it looks like a curved path, but it actually isn't, right? It's a nice curved path there. All right, let's keep going here.
I wonder, Andy, if you can answer this question. Do you have the prices right at your alleyway in the UK?
I don't know if they do or not. I'm sorry if they do. So here's another one too. Again, pretty faint though, right? Pretty faint, so we can skip that one. Here's an 11.1 magnitude star. So, you know, with an 8-inch scope, even a 6-inch, you'll be able to see that one. Let's see where it's going here. It looks like, yeah, it is missing the UK, right? It's going way north, way north. So let's keep looking here. There's one. Here's one. China, Russia, Europe. So here's a 10.4 magnitude asteroid passing in front of an 11.5 magnitude star. So, but it's a long one, right? 10.9 seconds. So that's a nice long one. But well, once again, here's the UK up here. No, it's going right through China, right through all of Europe except for the UK.
You know, there's like a saying that you can actually drill a hole and go all the way up to China that way, but that's usually not true.
Yeah, it's you know, I believe that's called a nodal point or an anti-nodal point, and every place on a sphere has one. Yeah, yeah. Here's another one. Europe and Africa. Oh, so this is a pretty bright star, magnitude 10.6. Well, nope, not that one either. Dang. As I said, you know, from
I've
from
gone all
any
right to Moscow.
yeah, from any location on Earth, you'll have a couple of chances a year.
Well, scroll back up. Scroll back. I just saw one that's for southeastern United States. I wonder. Let me see. Keep
That one?
right there. Yeah, the one.
Nope, it's going south of you. That's extremely southeastern United States. That's about as southeastern as you can get. Let's see. So here's another one. Europe. Let's see. There's another, or there's actually a program that you can download and run. It's called Occult, OCCULT 4, and it takes a little bit of setup to actually get it, you know, set up to run, but that'll actually make some pretty good predictions too. Instead of, you know, having to scroll through all this stuff, you can actually run this program, and it'll tell you, you know, what events are going to be happening over your location. I sort of like this one, you know, because, you know, we can sort of, you know, share my screen here and go through it. Arabia and Europe. So a magnitude 11.8. That's getting a little, you know, with an 8-inch telescope in a dark sky, you can see a 13th magnitude star, right? It's a little hard, but you can definitely see it. So if you can find yourself a relatively dark site, magnitude 11.8, no problem. No problem. But again, no, it's not going through the UK. Right? It's going through Eastern Europe, it looks like there.
Probably all about Bulgarian stuff.
Yeah. Okay, so here's a bright one, right? Asteroid America is going to be passing in front of a 9.2 magnitude star. Did you know that there was an asteroid named America?
No, I would never know.
I didn't know that.
Mind-boggling. You're boggling my mind now with that.
I am blowing your mind. Well, this looks like maybe it's going through just the southern edge of the UK. So maybe let's take a look at that one. All right, so that's happening on March 13th. So let's go over here again and look at it on a Google map. There it is, number 916, America. And oh yeah, let's see.
Baby gravy.
All right, Andy. Well, I don't know if you're in southern England or maybe southern Ireland, but if you are, right, this I would say would be a pretty good candidate, right? Because yeah, it's going right through there. And let's go back here. Can actually get the timings here. So it starts at 22:03, right over here, 3, 4, 5, 6, 7, 8, 9, 10, 11. So at 22:11, right, the prediction is that it's going to be passing over extreme southern England here. It's a pretty short occultation too, right? 2.2.
I think he's like in the deep south of the super deep south of the UK. It says that what we're looking at right now would be over him for sure.
Oh, okay. Well, Andy, I would say this would be an excellent opportunity for you to see an occultation.
And
Now,
Andy, I hope you didn't hear my question, but you have the prices right in the UK? The game show Prices Right?
the TV show, right?
Yeah, like game show.
Yeah, yeah. The only downside I see to this occultation is that it's really, really short, right? It's only a couple of seconds maximum. So, depending on where you are in this path, right?
New Force. Maybe if we do like a Google map search of New Force.
New Force.
Yeah, FORST.
Yeah. Well, he's looking at this map. He knows where he is. That's good enough as far as I'm concerned. Um, so yeah.
And thank you, Andy, for answering my question.
Yeah. So, yes or no? No, we do not. Okay. All right. Well, cool. Anyway, Andy, I would say, this might be an interesting opportunity, and you can actually relatively easily, and I can actually describe how to actually make a contribution to the data pool. It's actually pretty easy. What I've done in the past, right, is at at least a day or so before the occultation, what I will do, right, is I'll go to these finder charts, right, and I will find that star, right. I'm going to find that star, right. I'm going to know exactly where it is. So when the occultation actually occurs, right, I'm not going to have to mess around with, trying to have to find it for the first time, right? I'm going to know exactly where it is in the sky. I'll be able to point the scope there and bang, right? I'm there, right? So I don't have to mess with that. So, a couple of days or, the evening before the occultation, go out and find that star, right? And then you'll have to remember, right? Which shouldn't be too hard. And then the time of the occultation, what I've done, right, is I think in the UK, I don't know what kind of timing thing they have over the radio, right? But at least here in the United States, we have the WWV, right? Bobby,
Whiskey Victor.
Yeah, what do they have over there? Do you know?
Wait a minute. What are you talking about?
Do they have like an equivalent of WWV over in Europe, over in England?
No. WWE. It's more the same.
Okay, so it's called WWE over there?
Yeah, Whiskey Echo.
Oh, cool. Okay, all right. Anyway, so what I do, right, is I grab my shortwave and I tune into WWV over here, Victor.
Yeah. Oh, wait a minute. Wait a minute. I'm getting a little bit confused. Were you talking about like wrestling or time signal stations?
I'm talking about time signal stations.
Okay. 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 So sorry, I got a little bit confused on that. So sorry, y'all. So I think I'm not sure if the UK has a time signal station, but usually like there's Italy cable that does time signal.
Okay.
So I don't know what kind. I know there's the Russian RWM that does time signal.
Mm-hmm.
The BPM in China. You should know about WWB and CHU. That's for sure.
Okay. Anyway,
but any UK time signal stations, I don't know what's this, I don't know what this called and stuff. Maybe
right.
if we could do like a Wikipedia thing, and maybe there might be a list of time signal stations.
Yeah.
I think
yeah.
that would be good.
Well, what you need to find, right, when you're doing it, this kind of observation, what you need to find is a real time clock, right? You can't have an internet clock. You can't have all of this, you know, and it needs to be extremely precise, right? And because these timings, you know, only last a couple of seconds, right? So, you know, if your clock on your computer is off, you know, by 10 seconds, you know, your measurement's going to be off, right? So you need some kind of real-time signal of some sort. And I would think that England and Europe has something, right? Anyway, so what I do, right, is I turn on my shortwave and I tune into the WWV, and I have that running in the background. And then I take an audio recorder, right? And it can be anything, right? Some kind of audio recorder. It can be your smartphone, you know, anything to record audio, right? And what you do is, you know, position your recording device such that, you know, it can hear the time signal and it'll be able to hear you. Because what you're going to do, right, is you're going to put your eyeballs onto your telescope and you're going to stare at this star, right? And I would say start looking at this star maybe 5 or 10 minutes before the occultation is supposed to take place. And, you know, this is sort of the tedious part, right? But keep an eye on it because it could happen any moment, right? But at least according to the prediction, right, it's supposed to happen at 22:11 UTC. So I think that is actually going to be what 10:11 p.m. In the evening for you, right? So that's actually kind of a reasonable time too. It's not, you know, 2 o'clock in the morning. So, but you know, keep your eyes peeled, right? And when you see that star vanish, right, you yell, right? Just go, hup, right? And when you see it reappear, you yell again, right? Then you have a recording, right, of your time and when the occultation actually occurred. Then you can go into like a program, like, you know, some kind of piece of software where you can see the time signal and actually see your voice, and actually get a very, very accurate timing of this thing, right? You're going to have to take into account your reaction time and all of that. And then there are actual sites. There's a site to report that data. And I'm gonna have to remind myself what that site is. I think it might be IOTA, the International Occultation Timing Association.
Okay. All right. So for Andy Conley, I found a couple of long wave time signal stations. I'm not sure if you're familiar with long wave signals all around Europe. Short wave wise, let me see. I'm just going slowly down the list. I think the only thing that that Andy's got for his location are usually for the long wave time signal stations. I don't see any European time unless you want to deal with Russia.
Okay. Well, here's the
Okay.
And
Uncle Bill Duran as yeah, the UK equivalent of WWB is NPL and Anthem Columbia. I'm gonna take a look at that.
Cumbria. Cool. All right. Well, thanks, Uncle Bill. Yeah, cool. So you know, make an audio recording of you know, your live time, and you know, just shout out, right, when you see, you know, the star vanish and when it reappears, and then you can go to this site and actually, you know, sort of officially uh, um, record your observation for all posterity, right? So I think it is pretty cool. Here's some results actually from Europe. 2019 updated. So yeah, this is really hard to see. Zoom in here. So there was actually an observation made on February 15th.
Yeah. So looking at Uncle Bill's Wikipedia, I think it's still like mostly like in long wave format, but I think they still have it in short wave. I'm not sure.
Okay. Well, yeah, you know, you'll definitely need some kind of live, real-time clock, because you know, you want to be as accurate and precise as you possibly can, right? For sure. So anyways, yes, you know, so here's some observations made.
And they could have told me that the frequencies and stuff. I don't know why it won't tell you the frequencies.
Oh, well, you know, you just have to guess. But yeah, so you know, after you make your observation and get your timings and stuff, you can actually record this information over on, you know, the these sites, and you know, contribute to that stuff, and that actually helps in two ways, right? One, it helps get.
But I think it's mostly exclusive for long wave and stuff like that.
All right.
Not short wave.
Okay. You'll be able to contribute to helping determine a better orbit for these asteroids. Most asteroids, the orbits are really terrible, really terrible, because there just aren't a lot of observations, right? I mean, there are a lot of observations, but you know, there aren't enough. And the other thing that you'll be able to contribute to is actually determining the size and shape of these asteroids, right? So yeah, you know, it's making an interesting kind of a contribution. All this data is, of course, you know, fully available, you know, to anybody too, you know. So if you're interested in actually doing the work in working out, you know, the orbits and the shapes and sizes and stuff, you can do that too. So, but yeah, I would say mark your calendar for your evening of March 13th. and see if you can see asteroid America pass in front of the star HIP 53812. It's a
Yeah, so
pretty bright star.
MSF is at 60 kilohertz, and then they got an exclusive BBC 4, Radio 4, that does it in 198 kilohertz.
Cool. I wonder if over in the UK they have some kind of service on the phone, right? I think they have that here in the United States still, right? You can actually call a phone number.
Yeah, for sure. Yeah, I think you just call in WWB or WWBH, and you can still get the time in real time format.
Is that real time?
The reason why they're not doing it under internet, because there's a latency delay.
Oh yeah,
and you may not get the right one.
Yep, that is absolutely no good. You cannot use an internet clock at all. I guess, you know, if you're really,
I think if we can develop something that can WAN the latency factor, maybe it would be better. But that's like me and stuff.
Yeah, I think, you know, if you synchronized your clock on your computer or on your phone a couple hours before the event and stuff, that's probably good enough, right? You know, because your computer clock or your phone clock isn't going to lose that much time over a couple hours, right? So you could do it that way too, right? You can synchronize, but at least if you want to do, you know, the audio thing, you would need, you know, some way of recording the time on your recording device. But yeah.
And I think what I can do, I'm gonna post where I will go, and maybe log on to a European Kiwi SDR receiver and see about these long wave and short wave clocks in the UK for sure.
Cool, very, very cool. Anyway, so yeah, like I said, you know, pretty much anywhere you are on this planet, you have the opportunity to not go anywhere, right, at all, and see an occultation at least once a year, if not more, right? And if you're willing to drive a little ways, right, then you know, you'd easily be able to see, you know, one a month, right? So you know, if you're into those kinds of things, I definitely encourage you to do that, because one, it's a rush, right? I mean, it's really, really, really cool to actually see something happening quickly, right? Usually, you know, when we look up in the sky, it always seems to be exactly the same, right? Now we know for a fact that is not true, right? And in fact, you know, the more we look and the harder we look, the more we see that things are really happening constantly, right? On all different kinds of time scales, right? From microsecond pulsars to you know, thousands and thousands of year variable stars, right? So and everything, all those things, you know, between that. So Andy, what I would say is you know, that prediction is probably going to be updated, right? So what you might want to do is I think you might be able to email these folks and ask them to run a new prediction for you, and they might. Or you can get that piece of software. It's called Occult 4, and in fact, I'll post a link to it here. Let me find it. Let me find it here, and then I will post it in the chat. And then you'll be able to run it on your own computer for your exact location, right? And that is ideal, right? And because you do want to make sure that at least the prediction says that it's going to happen at your location. But yeah, don't necessarily trust what I showed you. That's likely, but always not the case. Like what started this today was us talking about the occultation of Sirius, right? And the fact that it was predicted to be able to be seen just to the east of me, right? And so I was kind of like, well, maybe I should take a look, right? Well, a new prediction came out, and that put it at least 1,000 miles east of that. So it's and the same kind of thing could happen here. So definitely figure out a way to get a up-to-date prediction. But anyway, this is kind of a fun way of finding out if these kinds of events, are going to be taking place near you, and you can sort of plan for it and see what you can do. And like I said, it's a pretty good rush. It's a pretty interesting rush. This particular event is going to be really fast, right? I mean, it's 2 seconds maximum. So you've got to keep your eyes peeled. Like I said, start really paying attention maybe 5 or 10 minutes before the event, because you never know exactly when it's going to happen. And it could be several minutes off. Either way, this prediction says 2211, but it could be, if that path is actually correct, it could be 22:09 or 22:13, somewhere in there. So you got to keep your eyes peeled, which is not always easy, right? The other thing that you can do, right, and more sophisticated observers, right, they actually have video cameras with a timestamp actually on each video frame, and so they can record this at 30 frames a second or 60 frames a second, and get very accurate timings that way too. But that takes a lot more setup. What I'm suggesting is the easy way. So, all right. Well, everybody, I think I'm going to get out of here for now. I really like occultations. I haven't seen an occultation in a while, so I'm sort of wanting to do that at some point again. Yeah, they're really, really fun. All right. Well, I'm going to get out of here for now. So take care, everybody. Have a great evening, a great day. Make sure to subscribe if you haven't already. Spread the word about this, right? We're sitting here.
Just like a friendly reminder that tomorrow I'm going to be doing another risky echo viewing party.
Cool. Well, have a good time. Have a great time. My wish for everyone, right, is to have the most fun that you can possibly have, right? So be it here, be it somewhere else. It's awesome. Yeah. So have a good time. I think viewing parties are always fun. They sound fun at least. So cool. Very, very cool. All right. Well, like I said, share this around. This is just a fun, casual get together. There's never really any topic of sorts. We're sort of still talking about the constellation Leo. I haven't forgotten, but we go off on these tangents and stuff. That's okay. That's all right. If I was doing this every week or every month, I would probably want to stick more on topic. It's like, no, we need to talk about Leo and But look, we're here every single day. It's laid back, casual, fun. So, if we don't talk about stars and other objects in the constellation of Leo today, we'll probably get to it tomorrow or the next day, right? And Leo's a big constellation. It's got a lot of stuff in it. So we're just going to sort of slowly go through it and take our time and see what it has to offer. It's a busy place. It's a busy place. So, all right, everybody, take care. Peace, cheers, and all that. I will see you on the spin. See you later. Bye.
Live long and prosper.
You betcha. All right. Bye.